This is Piecewise Functions, example 6. We have a piecewise function, and we want to graph it. So we're going to take each piece at a time. So I'm going to graph x plus 8 on the interval of x is smaller than -3 first. So to do so, I've drawn some coordinates. And we want to find where the interval starts and ends. So we have x is smaller than -3. So we need to look at where -3 is. We found it. X is -3. And we want to solve for x plus 8 when x is equal to 3, even though it is less than 3. It'll be an open circle at x is -3. So when x is -3, we have -3 plus 8. It'll be 5. So our point at -3 will be at 5. It'll be an open circle because it does not technically include this point on this interval. And then we need another point to graph it. So if we pick any arbitrary point that is less than -3, such as -4, if x is -4, then -4 plus 8 is 4. So at -4 it is 4, and it will include that point. We can then graph it. It'll also have an x-intercept at x is equal to 8. So if we draw a line through there, it'll continue to -infinity. So we've done the first piecewise function. Next we need to look at the next function, which is f of x is equal to x on the interval between -3 and 3. It is equal to -3, but it does not include 3, so we need to make sure of those boundaries. So looking at the boundary of -3 first, if we plug -3 into our function x here, we get -3, -3. So at -3 we have the point -3, and it does include it because it was greater than or equal to that point. If we look at our other boundary when it is smaller than 3, not including 3, so it'll be an open circle, we have the point 3, 3, substituting x equals 3 into x. So we have the point 3, 3 not including 3, because it is smaller than but not equal to. So we have a line going from -3 to 3 like that. And for our last function, we have it is equal to 4 if x is greater or equal to 3. So this is including x is equal to 3. So at the boundary of 3, f of x will equal 4. So at 3, you'll equal 4. So we have a point there. And this is a horizontal line that just goes on forever in that direction. And we have successfully graphed our piecewise function. What's important to note is that there are no overlaps. For example, here at f of -3, it includes -3 for this function, but not at this function. And here when we have at x is 3, we do not include it in this blue function, but we do include it in this green function. So our function includes all values of x, but it does not overlap, and that is very important. If we want to see it instead of drawing, using technology, here's Desmos, where I've graphed the piecewise function. It looks the same, as you can see. And we can see that at our boundaries, even on the Desmos graphing calculator, it will not equal the boundaries unless it actually equals this. So here where f of x is equal to 4, it includes the boundary of x equals 3, so it includes the point 3, 4. But here, where it doesn't include 3, it'll go up to 2.9995, but it will not include 3. And a similar thing down here, where we have the point of -3, -3 for this function that includes x equals -3. But up here, it'll always be less than negative 3. It'll go as close to negative 3 as negative 3.01, 0.02, but it'll never actually go all the way down to negative 3 on this function right here. So it's very important to make sure that our functions, our piecewise functions, do not overlap.